show to us, he can.
Yeah. All right. Hey everyone. Today we're just going to be doing a little, and we will be working on predicting traffic data using a LSTM RNN. So this is the project, and we will be using this Jupyter notebook to train a model that will predict the the traffic data. Is that the one? Victor, do you think we should do the traffic data one? You can use your mic if you want.
Yeah,
Hello?
that one is good.
How far did you get?
So I was able to train the model, but trying to like predict. I was having trouble like transforming the data to fit the example that we had. I was
Oh,
able
cool.
to train the model and predict.
Could you show us how far you got, or at least the code that you wrote, and then we'll finish it?
Oh yeah, sure.
That would be great.
Can I just drop a link because I'm not on my PC at the moment?
Oh, okay, yeah, yeah. Can you
Um,
add me to that collab notebook,
all right, sure.
and we can go through it, and I can add Naveed as well. I can add anyone. So let's have a look at the data set. So it was this one, right? Let's see.
Yeah.
So we have time of day, the day of the month, the day of the week, the number of cars on the road, number of bikes, the number of buses, trucks, in total. And this should be probably this traffic situation, Naveed, we should probably have to calculate it from the earlier columns, right?
You're asking me?
Yeah, I mean, this looks like it's something. This looks like it's feature engineered here. Just
Yeah. So I
Traffic situation.
predicted against the total. So it was the time against the total.
here it is. Cool. So, Victor, you can see this, right?
Yes, I can.
Okay. So, I see what you did here. I'll need to upload that CSV for this to work. And then, did you have to change anything here? Yeah, you did actually, didn't you?
Yes, I converted the time to minutes. So it was like for different time, both AM and PM.
So the time that they gave you is in the format of this, right? But you needed to change it to this.
Yeah.
So the minutes after midnight, something like that.
Yeah, exactly.
Okay, that makes sense. And then did you also have to combine the time and the date as well? Oh, did you do that as well? You combined the date, the date.
No, I didn't use this. I just used to like explore the data. You could just scroll down, you see when I used.
Got it.
So
this is
it was
one day.
Yeah, like the peak of each time.
Oh, that's so neat, actually. So this is the morning rush hour and the evening rush hour.
Yeah.
That's super cool. Okay.
Where's this traffic data from?
From Cargo. And one of the links you added in the GitHub page.
from Khartoum.
Yeah, cargo. Let me see. I think you already showed it earlier.
Yeah, here.
Is that a
Yeah.
place? I thought he's saying Kegel.
Oh, from Kaggle.
I mean, I'm just curious, like what
Yeah.
location this is from.
Is there something in the description?
Yeah, let's have a look. Data
On the
card.
data card. Yeah, this is duration and
It says it's from an urban area. I don't see anything.
they haven't mentioned this the place.
That's all right.
Is it? Now we're so curious. It's a bit strange though not to know that. It seems like an important. Yeah, no, I don't see here. It's under discussion. Dataset source. Okay, yeah. So other people are wondering as well. Like, what is this? Oh, that's interesting. So it looks like this might be simulated data.
Mm-hmm.
I don't know if you can see that. Yeah. So it looks like this is like simulated data that he using probably a non deep learning type model, like a SimCity kind of thing. Cool. So Victor, is this can you explain this X train? So have you combined, is it like a whole month of data or is it a day?
So I just took the whole data set and used it. So I didn't use the aggregation I did earlier. I just used that for visualizing the data.
So you actually don't need the timestamps to train the model. You just took all of the data in order, right? Because it's sorted by, it should be sorted by time anyways.
Yeah, it seems like this is the data is collected at 15 minutes timestamp.
Yeah.
So
it's
he
perfect.
has just extracted if you look at the time which he has extracted varies in 15. So can you scroll up? Yeah, here. So if you look at time, it's 0, 15, 30, 45, 60, and so on. So it's varying in 15 minutes interval. And then you have the total, which is the count of the traffic. No, it's not the count. It's actually the aggregated sum. So he's taking the mean of it.
Okay, got it. And yeah, so if you'd have 14, 24 in 15-minute chunks, or rather, so this is the number of minutes. So that would be 23 hours. So this is one day in this data set. So now I was just curious how many days are in the total thing that we're training. So, okay. Did you have to change anything in this?
No, I didn't. I just used the exact same on the example.
Okay, cool. Let me run it myself.
Okay.
Too many sessions. What else am I doing? Yeah, that one. My Bitcoin is running in the background. So
they don't allow you to use multiple GPU sessions. You can run multiple CPU sessions, but not GPU. It's costly.
Yeah. But it's nice that you can have one for free.
Yeah.
Let's see. Just download this. Lost the model. Let's see. It's called Oh, okay. It's called archive.zip. Okay. Got it. Traffic.csv.
Remind me in the end, I'll show you a model which I used for predicting website clicks. And I used XGBoost for that.
So is that was also prediction?
Yeah, it was 1 day ahead forecasting.
What?
So yeah, it's that open loop thing.
Okay. That trained super fast. So
Yeah,
got it.
because the data is really small.
Okay. So
So this is where I stopped at. I couldn't go past this.
okay, yeah, it looks like you have an issue with the time stamps or something
Yeah.
like that.
Yeah.
So basically,
It would be really difficult to plot the forecasting using the format that we like. The code used the format which is different from what Vector has done. So he's not. I mean, he's not looking into the time format in the way that James you looked into for the previous data. That's why.
so let's have
Mm.
let's have a look at the output of the model.
So you can just simply plot the prediction and the true trend without looking into the date.
Right. Okay, that's a good idea. Because this looks like this is the time on different days, or is this the time on the same day?
It's on the same day, but on different. I'm not sure because even the minutes are not changing here.
Yeah, so that's obviously why we're having this graph where
Yeah,
things are
because
not.
yeah, it's plotted against the time, which is scrambled. It's not correct
Okay.
for this example.
So we would change this to
You can, I think you can just simply remove that and just plot
really?
just plot the y-axis. I think it should work.
Okay. Yeah.
Wow, it worked.
How easy. Okay. It works. Of course, and all of that work that I did on that, all of that work was just so that this x-axis would show the times.
Yep.
So
Mm.
we could have maybe removed that code to make it simpler for you all, but I don't want to make it too easy.
Yeah, but this way it would not be. I mean, you cannot read it then, which value occurs at what timestamp, which could be a useful information. That's why you have to work with the correct formatting of the date.
Yeah. Of course, you want to have the right axes on your charts. This is the same. Oh yeah, of course. So I was supposed to use a subset here, but
You have to zoom into the last few values.
yeah, that's what this next chart is for. So I will do it like this, maybe like this. Yeah. See if that works. Okay.
Yep.
This
Wow.
So this is just the last 50 values.
50.
So that's like 10 hours or half a day. Looks pretty good.
Yeah. Probably if I train this for longer, I'll probably have a more accurate results.
Maybe. So
How much epochs did this took to train?
10 epochs.
10 is a very small number, so if you train it for, let's say, 100, maybe it would be even more.
All right.
And we can calculate the accuracy of the model. I'm starting to realize that these models are really only, the results of the models are really only interesting once you start to put them to practice and test them in a real world situation. So, what mistake did I make?
Sample numbers are inconsistent.
Yeah, what did I do here?
Right.
So we here above.
Yeah, actually, James, the upper array where you are plotting the correct values, they are taking the entire data, and the forecast is just taking the last of them. So
Oh,
you need
really?
to,
I need
yeah,
to.
you need to match the numbers, like just.
Oh, right, of course.
the last.
Because here, yeah, I'm taking these two lines and passing them both in.
Yep.
So, okay. Well, there's a really quick way to do that, which is probably just
Yep.
like this and this, so that, something like that.
Yep.
Almost.
Let's see. Is it still not matching?
What are the dimensions of
2833143?
Oh.
It's not taking. It's still not.
So this is like. How do I get the dimensions of something like this? What's that again? Size? What's
I think it's shape. Dot shape or something.
Shape?
Shape works with NumPy arrays. Oh,
to work.
okay. So you have.
Uh,
143.
Okay, so this one should be 43. Okay, that didn't do anything.
You are indexing it incorrectly. Can you remove the negative sign? Yeah.
I think I did that above too.
Yep.
Oops. Okay. Thanks, Naveed. So, mean absolute percentage error of the forecast.
Seems huge.
That's a lot. but let's look at, what does this really mean? The mean absolute percentage error. It's like divided by that. For every.
It's taking, yeah, the actual value, subtracting the forecasted, and dividing it with the actual. So in other words, it's kind of normalizing in order to remove the effects of the different scales of the values.
So it's exactly what this says, actually. It's the mean absolute percentage error for every point. Interesting.
But this value doesn't. It can change. It can even go above the 100% limit.
Sure. Yeah. Okay, so that's pretty interesting. So this is quite high, and if we look at this one here, maybe I'll look here and go a little bit more. Yeah, it doesn't seem to be too far off on a lot of these cases. That's interesting. Like the biggest error that I see is here in these low periods. It's overestimating. And then here at the high, sometimes it underestimates.
Can you go back to the code where it is calculating the map?
Yeah, here.
Yeah, let's see. So
maybe there's something wrong with this, or maybe it's giving back is this a percentage?
mean absolute, yeah. Because it is getting multiplied with 100 if you look at the formula for map.
Oh, yeah, it is.
There's 100.
In the formula. So
Yeah,
so in fact that would mean this is incredibly low. That's what we're saying.
yeah.
So
It's it's kind of 0.75%.
right. So I could, if I really wanted to verify what this is doing, I can do something like this. 0.5. Well, that's 50. No, that this is
Okay,
so,
can you change the values? Maybe make it 2 and 3 or something.
but that would mean that this is actually not multiplied by 100 in this case, right? So because percent error.
2 minus 3 is -1, and then divided by 2 is 1.5.
Yeah, right.
It's not getting multiplied.
So
It's not getting multiplied.
so then this is a huge error.
It seems to be a
Probably
huge error.
the wrong subset of data. It's not possible.
Well, we can.
Can we check how we did it above? When we're able to get the subsets.
We can just have a look at the data. So
Yep.
we want this one. It's possible that I've made a mistake here. I should probably plot these two. That would make a lot more sense. Plot these two that I'm using directly.
I think you are plotting it here.
Here with the window size, yeah. So let's see a total, but I want to plot exactly what I'm passing into the error function. So that one and this one. Okay. Aha.
Actually, can you convert them into numpy arrays before plotting?
Could this be part of the issue though?
Yeah, because it is a data frame, and that's why it's taking into account the index, which is why it's plotting this chunk at the beginning and the other chunk at the end. Convert both of them to call the dot to numpy on it on both of them.
To numpy, okay. Yeah, I still think just getting the last. That's odd. So they're not lined up anymore. I took oops, I wanted the 0
Why did it appear correct earlier?
Yeah, it is correct in the earlier one. So this
James, I think it is because we have to remember we have to remove one window segment from the forecast one in order to align it. Just
Okay.
like we did for the last one.
Yeah, we did that. Let's have a look. So,
But
if
still, it
this one
doesn't seem.
would be-
I mean, even if you do that, it still seems like very vague. It doesn't seem like there's a mismatch of the index here. The forecast is just horrible.
it seems like this has to be shifted to here or something like that, right?
But
So
even if you do that, would it make it a reasonable forecast?
I think so. If this is shifted by, because this is at like 30, and then this should be around. If it was shifted by like 50. I see that. I see that shift. But I'm not sure how that cuts into the data. So the answer is these metrics are all wrong because we have the data is it's not comparing the right values with each other.
Can you just control Z everything where we got the correct pattern? What was happening there?
Oh yeah, sure. I mean that should still be here. Here.
Yeah, can you
Here.
plot it now?
Here. Okay, good. Move back to 250. Good.
Make it 143 because that's the length of the forecast.
Okay.
Yeah, and now pass these values to the metrics.
Oh, I see what I did. This is me. This is me, and like I don't know. Like recently, I've been making a lot of mistakes with this array format. So what I did when it worked well is this. What I did when it didn't work well was this.
Oh,
Yeah, see? Very similar but different. Because this takes all of the items after a certain index in the array, and this takes the last n items of the array.
I think
So
it's the other way around. So this one actually takes values starting from beginning up till window size.
up
But
to
when
the
you but when you put a negative sign, then I think what happens is it takes the values not from the start, but from the end of the array till that window size.
from the end, right?
Yeah.
So
So you should pass these values to the matrix.
yeah, and we want to get the whole forecast length as well. So I want to do
Yep.
I just want to do this, maybe something like this.
Yeah. It will
And this
still work.
be the whole forecast. But this is just for 1 day though, right?
It's for the entire forecast set, or I mean, the 5% test set that we have
Okay.
set
Yeah.
aside.
So it's it looks like 1.5 days or something that we predicted. Okay, great. So after all of that, we can do this. Okay, that looks better.
Yeah, it's kind of 15% now.
15% error, which is a lot more like what we're seeing here. Between values, you see value here that's like 30, and then it goes to 50. So that's the more range of the error that we're seeing. Cool. What do you think, Victor?
Alright, really nice. Maybe if I check for longer, I'll probably get a better result.
Yeah, and you can also experiment with the model itself. Can you scroll up to the model, James?
Yeah, of course. So
Yeah, so we just have one LS team there. Typically, since LS teams are very compute hungry, that's why two layers are usually enough, but you can increase the number of neurons in each LSTM. So here we have 64. You can even experiment with, let's say, 128 or 512 and add another LSTM there, and then maybe add another dense layer as well. That would be a pretty much complicated model, and then train it for, let's say, 100 or 200 epochs. And I'm confident that the prediction would be a lot more better than what you are seeing currently.
Alright,
yes,
thanks, Navi. I'll try that out.
try that at home.
Thanks.
So, any other questions on this, Felix or Nishant?
I dropped out for like a minute, so no questions.
Yeah, it was
Yeah.
pretty. I felt it was straightforward until we got to the part with slicing arrays. But even that is not too difficult if you're fully awake and paying attention.
Yep, no questions here as well.
Cool. So that would be the last. This is basically our last formal session. But you guys let us know what projects you're working on, and if you have a model you want to train, and we'll try and help you. We'll probably be for the next course that we're doing, we're probably going to change up things a lot, also based off of your feedback as well. So I'll be asking you all for feedback in the next week or so, and we'll keep you informed on what we decide to do next with this. We're also probably going to have like one catch-up session where I just help people debugging their projects, or maybe so I'll keep you informed about that. And look who it is.
Hello.
Just in time.
I mean, you guys are wrapping it up, innit?
You're late to the party.
How's the laptop? Is it
Wait, I
working?
just got it fixed. Yeah, I just got it fixed.
Oh, really?
Yeah, I just got
What was
home
wrong with
like
it?
5 minutes ago. Bro, it was the motherboard.
Oh,
That's not
Yeah.
good.
I'm glad it's fixed. Motherboard issues are usually fatal.
Was it expensive?
It was alright. Not that expensive.
That's a relief.
Mhm.
Yeah. Cool. So yeah, we were just wrapping this up. We did a project. We showed Victor's project, which was about
Alright.
traffic prediction.
Nice.
So it worked pretty well, predicting the traffic in a fake city.
Uh,
But we had a lot of data alignment issues, but
that's not too bad, but
the error is pretty low. Yeah, it's pretty predictable traffic. So
interesting.
that's the problem.
Data like this is really a piece of cake for neural networks. Where it struggles is, let me show you an example.
Yes, please.
Can you guys see my screen?
Loading. Now, yeah.
Yeah, so this is a data set for website clicks, and
Right.
it's data like this which is problematic because
Mhm.
it's really
Hmm.
uncertain. There are sudden spikes and then flat values like here you see,
Right.
and then very high spikes here. What I used for this one was XGBoost and another statistical technique called ARIMA, if you guys have heard about it.
Mhm.
It's not a machine learning technique, it's more considered of like
Yeah,
a
I've heard about
statistical.
Yeah, I've heard about Sarima, not Arima. I don't know if that's
Yeah,
different.
Serima is a. All of these are slight variations on the same technique.
Right.
So you see the results here. True values are in the
Mhm.
blue and XGBoost orange, and then Arima kind of. It seemed like Arima was doing a better job on data like this
Yeah.
than the machine learning models. I didn't try LSTM on this because the client that I was doing this for didn't ask me to do that. But
Right.
XGBoost can be considered closer to what a neural network could be doing. Um, its result was not that much impressive if you compare it with the one that Arima is getting us.
Right. No, I tried coding on my iPad. It was a bit
Hmm.
difficult, but I wasn't able to finish it. But you guys can have a look at least, maybe.
Yeah.
Sure.
I think I'm having some problem with the epochs, so maybe you guys can help me out.
Felix and Nishan, if you guys have to go, just let us know. It'll be okay. Or you can stick around.
Yeah, I'm okay for a bit. Yeah. Thanks.
Yeah, I'm also fine.
Cool.
Do you guys see it?
1 minute. Oh, Mr. Dark Mode over here.
Of course. You guys see it, right?
Yeah.
Yep.
Yeah.
Okay, we got the libraries, and wait, I can show you guys the data before we do anything else. So that's what the data actually looks like. This is from a coin that I'm looking at for the past 2 months, and you guys can see I'm currently in huge loss. But the thing is, this is like for a month, right? So it's like each day since the last month. So I've used this data. We got the date and the price. That's what I'm using for this data. I hope that makes sense.
Hmm.
And
How do you get
the,
this? Do you like scrape it
wait,
somewhere, or like
no,
how do you
no.
get this data?
It's actually from like wait, what was the
Place-
website's name?
Coinbase has it.
It was called investment.com or
Yeah.
shit, like something
But
similar
Coinbase
to
has
that.
yeah, which is free, at least. Coinbase,
Yeah.
CoinGecko. Yeah.
Mm-hmm.
Yeah, we can also use APIs and stuff, but like a Binance API and stuff. But I chose not to use it because I got the CSV like right away, so I didn't bother to check it. But like you guys can see the sharp decline over the year, over the month, and this is the current state.
Wait,
So
what's the lowest point? It's like 0 point
wait,
0.
no, it's not actually not that bad, but like the graph is like point 0.2 here, so it's between point 0.1 something. So uh, we got we split the data into 80/20, and this is the model summary. I used the one you guys used in the previous LSTM. Also, not to mention that this is like a very quick thingy. I didn't really give it enough time until now. And the thing is, when I train these epochs, this just keeps going for some reason. Don't know what's wrong.
Oh.
Yeah, you see the loss is like so. It's like minus to 10 power minus 6, and it keeps going on the first epoch. I'm not sure what's wrong. Maybe I can share the collab link too.
Wait,
I'll drop it in the
I had this
chat.
happen once too.
No. How much is the amount of data again?
Wait, it's like 1 month each day.
Yeah, but how many values?
Oh, it's like, wait, let me see. Uh, Give me a second. It's not that much, but yeah, I have shared my collab link too in the private chat if you want to have a look.
Did
Okay,
you happen
so
to find
we have
the
like
shape somewhere?
30, 30, 33, 33. 32 actually.
Just 32 values?
32 rows. Yeah, that's it.
What's
And
going on here
it keeps
then?
taking this long. Yeah, that's what I'm thinking.
Can you scroll down
Probably
again?
something to do with down or up.
Down.
I think
Okay,
probably
so
something to do with here. Yeah.
page size is 32. Right, split. It would be nice if we can can you stop the training and maybe print the trend data set, the trend data and the validation data values?
Yeah, sure. Yeah, maybe.
Eh,
We can also print shape, so it'll give us better idea about.
Yeah,
Later.
dot shape.
Oh, you want the shape too?
Yeah, because I want
Wait,
to see how many values are there.
wait. That's how we do it, right? Wait.
Yeah, if it's an umpire.
Yeah, it is.
I think also works for data frames.
Okay, sweet. Okay. 25 and 7.
Then what
For
is
this
going
split.
on here?
I have no idea. I've shared the Colab link too.
Okay, actually I have to leave the library, that's why I cannot look into the
Yeah,
code
it's
right now.
okay. Yeah, it's okay.
But
We
I
can have a
will
look at it
have a
later.
look at it later maybe.
Sure.
I had some strange instances when I was training my model as well. I don't remember exactly how I solved it. Sometimes just running the training again, I would get something different.
No, I actually
Yeah.
changed the computation power and tried again, but
Okay.
it didn't work out.
He's using a T4 GPU and there are just 25 values, so there's definitely something wrong.
Yeah, it's not to do with the processing power.
Yeah, nothing to do with that.
Okay. Cool. Well, then we'll wrap this up for today. Thanks for
Sure.
joining us, Borhan. Thanks everyone.
Thank you. It was a great experience throughout the course. Thank you so much.
Yeah.
Thanks,
hopefully-
James. Thanks, Naveed.
Felix.
Thanks,
Welcome,
Naveed. Thanks,
Felix.
James. Yeah.
Thanks, Nishan.
I'll continue working on the Bitcoin one with you. I'm really curious if it can be real.
Talk to you.
Do explore
where's the problem?
Yeah, do explore the Quant Connect website. That is a really useful place. It provides you
Yeah.
data sets and it also provides you a way to deploy your model into simulated environments where you can directly assess the performance of the model.
Cool.
Mhm. And Burhan, can you share the website where you got the data for the
Yeah, sure, I'll share it.
the coin prices? Yeah. Thanks.
I got you.
All right.
Thank you so much.
Thank you very much, Felix and James. No, not Felix, my bad. James and Naveed.
Thanks.
Welcome, Nishan.
We have
Alright.
shared the link in the private chat.
Great.
Thanks everyone.
Thanks, everyone. Nice
Thank
to
you.
meet you. Good to meet you.
Nice
Talk
to
to you
meet you.
soon.
Likewise. See you
Goodbye,
guys.
everyone.
Bye-bye.
Bye.